Hello, my fellow self-made coders and digital explorers. It's your buddy, the Web3 idiot, back with another adventure into the land of algorithms. Now, who's ready to uncover another treasure map that leads us to the heart of efficient coding? Today, we're talking about the selection sort algorithm, a simple, intuitive method that's all about, selecting. Imagine choosing the captain of your dodgeball team in school, or picking the right tools for a camping trip. Sounds a little less intimidating if you put it that way. I know diving into algorithms can seem like trying to read hieroglyphics without a Rosetta Stone, but that's the beauty of our journey, taking the complex and making it not just understandable, but actually a bit fun and humorous. And if you've ever felt like you've hit a wall with learning to code because data structures and algorithms sound daunting, this is your safe haven. So, what's this selection store all about? It's a pretty neat way to arrange items in order, be it numbers, letters, whatever elements you throw at it. We're going to break it down step by step, and I promise by the end of this video, you'll have cracked another code in your programming journey. So, ready to turn confusion into clarity and have a good time doing it? Let's dive into the world of selection sort, unravel its secrets, and add another powerful tool to your self-taught coder's toolkit. Onward we go! So here we go. We have a selection sort. It is a pretty easy to understand sorting mechanism. So we're just going to go on. So for input, just like most ways, we will be given it an array. So you have 7, 6, 5, 4, 3, 2, and 1. We're just going to stick with a very simple array. And our output array will be 1, 2, 3, 4, 5, 6, and 7. Hopefully you are able to keep up. What we're doing is we're taking 7, 6, 5, 4, 3, 2, 1 and ordering them from least to greatest. 1, 2, 3, 4, 5, 6, and 7. So, what exactly is selection sort? The idea is that at the beginning of our array over here, we will find the smallest number in our array and put it there. And then we move forward a step because we know that the smallest one is already to the left. And we look for the smallest number in the remaining digits. And from there, we put that in index spot 1. And we do so on and on and on. So for example, let's say that we have our array here. We're just going to write it out again. 7, 6, 5, 4, 3, 2, and 1. And what we will do is we will have a thing here that will keep track of our minimum value. We'll call it M. And down here, we will call it C. So C is our current place that we're looking at. And then we will also have, oh no, not complexity. We have C here. And then we also have I. I will be keeping track of the index where we'll be inserting our selected value. So first up, we'll say C. At C is an index of I, which is 0. So 7 is already our lowest number. So next up, we'll move over. We'll take a look at number 6. And we'll take a look at 6, and we will compare it to our minimum value right now, or current minimum. And of course, that is a 7, so our new minimum is 6. We'll move on to 5. Compare 5 to 6. 5 is, of course, less than 6, so our minimum moves up. Then we come over here. C moves over here. Current is 4. We compare it to 5. Minimum moves up. Next up, we compare our current 3 to 4. Minimum moves up again. C, 2 to 3. Minimum moves up. And C here, 1 to 2. Minimum moves up. And C has broken out of our array. So this is what we do. We take M, we take I, and we switch them. So 7 will now be back here. 1 will be back here, and our I will move up to index of 1, the second position. And we will reset everything again. So M, our current minimum, will be this 6 here. And our current pointer will move forward 1. It is a 5, which will update our minimum to 5. Current pointer will move up again to 4. It is less than 5. Minimum move up. Here we have 3 compared to 4. Minimum will move up again. Current pointer will move up to 2. It is less than 3. It will move up. And then here C will get to 7. It is not less than 2. So 2 will be our new minimum, and we'll switch this one with I. So 2 will come over here, 6 will come over here, and we will move I forward. Our new I pointer will be there. So 5 is our new start for our current pointer, and it is also our current minimum value that we see right now in the that we've gone through. So C will move up to 4. Oh no, 4 is definitely less than 5. M moves up. C moves to 3. M moves up because 3 is now less than 4. Current moves to 6. The minimum is still less than 6. C moves up to 7. M is still less than 7. So M will switch places with I. So here, 3, 5. Then we'll reset again. Now, it's already sorted, but that is because we gave it a very, very, very simple array to sort. So C will move up, move up, move up. 4 will stay. I will move up to 5. M will move up to 5. C will restart at 5. All right. Moves up to 6. 6 is greater than 5, so we'll keep our minimum at 5. Same thing with this. We'll move up, up. Here, same thing. Blah, blah, blah. Bum, bum, and bum. There we go. And we have a sorted array. All right. So what are our pros? Our pros are it's quite easy to code and understand. All right. Very easy to understand this code. We know that we are looking for the smallest number in the remaining numbers. And when we find it, we swap it with the current index pointer. Okay. So that is our question. So what is the cons? Our con is it will take a long time. A lot of these lower level sorting codes that we will start out with, they don't have the best time complexity compared to some of the more advanced sorting methods that we will look into later on. So when you're dealing with small data sets, it doesn't matter at that point. But when you get into, more of the data sciencey area, back end, you're dealing with millions and millions of lines of code. And also millions of lines of data. And those milliseconds add up. So that is an issue. Yeah. So our con is it takes a lot of time. Boom. Here we go. All right, next up, we're going to get into our pseudocode. So first up, we will init a function called, what would we call it? Oh, I know what we'll call it. Selection sort. And inside, we will pass it an array. All right, first up, inside of our selection sort function, we need to init. No, we do not need to init. Where are we at? We need to do a loop. That's what we need to do. So the first thing we did is we loop through one time. So we'll do a for loop. And I will start at 0. This is our pointer that we move through. This one right here. And we'll say I is less than array.length. Technically, we would do array.length -1 because we don't need to check this last digit, but just for the sake and simplicity of this code, we'll keep it like this, and we'll iterate I up. So I will iterate up by 1. Inside of this loop, what do we need to do? We need to keep track of our minimum, our current minimum. What is it called? Current min. And I want to keep track of this index, okay? So we're going to start out with I because that will be the first value that we see. So we'll come down here and we're going to do another loop. So basically we have 4 and then a for loop. Again, we're going to be using j, and j will equal I plus 1. Because we're not comparing I to itself, we want to compare I to the value next to it the first time. And then here we'll say j is less than array length, because we only want to go until the end of our array. And here we'll say j plus plus. Now, here's the fun stuff, okay? This is where we start comparing our numbers. It's basically, what we're going to do is, if we see that array of j, all right, is not greater than, it is less than the, we'll do array, and here we need to find the current minimum. So this current min here is holding on to the index at where it's at, the array at current min. If this is true, then we will say that current min is equal to j. And then we will move on. And then after we break out of this loop, we will say that we'll have to swap the values where array at I and array at current min will switch places. And finally, we will return our sorted array. So by the end of these 2 for loops, we should have a sorted array. So let's move on to time complexity and space complexity of selection sort. So I guess the basic idea would be that we are going through this n times, and for each n we'll do it n more times. So similar to the bubble sort, it is n times n, which is equal to n squared, which is not good. It is very terrible. And then here we have our space complexity. We are not creating a new array. We're just moving elements around or values around inside the array. So our big O will be O of 1 because we're not creating anything new. All right, let's get into the actual coding of it. So first up, we'll have a function. And this function will be called selection sort. And we'll pass it an array. All right, so that is this line here, 22. Let's move on to 24. All right, we're going to init our first loop. So for let I equal 0, I is less than array dot length. And really, it should be array dot length minus 1 because we do not want to get to the very last one because there's nothing to compare it to. And we will increase I every time we go through. Next up on 25, we need to initialize a variable to keep track of the index of our current minimum value that we have seen as we iterate through the array. So let current min equal I, because that is where we're starting at. And then we'll initialize our second loop. So for let j equal, remember, has to be comparing to I next to it, the next to the I. Again, j is less than array.length. We do not want to go to -1 because we want to make it all the way to the end. And here we say j plus plus. We will increase j every time. So how do we do this? We use an if comparison statement. So if array at position j, okay, if array at position j is less than, we're looking for the smallest number, the array at position current min, so this is the index of the current lowest number, then we will say current min is equal to j. Boom, there we go. We have that done. And we will break out of that. So we are moving on to line 30. So remember, there are two ways that we can do this. Remember, our first way is let temp equal array at j. Array at j is now equal to array at, we're not saying array at j, we're saying array at current min. And current min, and we're switching with array of I. So this array of I is our sorted item. And then here we'll say array of I is equal to temp. So this is the value that we saved that was erased when we switched it to this one here. So that is one way of doing it, but also remember we have a way of deconstructing it where, this is my favorite way of doing it. So we have a array, and inside the array we'll say array of, what is it, I, comma, array of current min is equal to array of current min and array of I. So remember, we're just switching them before the values inside get removed completely and replaced. So at this point, we have sorted everything. It's on line 30. And finally, we're moving on to our last line, which is returning the array. All right, so let's go and let's make a test array. Let test array equal 7, 6, 5, 4, 3, 2, 1. Very good. And what we're going to do is going to console.log, and we will console.log selection sort, and inside we will pass test array. So if everything goes according to plan, we will get 1, 2, 3, 4, 5, 6, 7 over here. Let's go ahead and hit that run. 1, 2, 3, 4, 5, 6, and 7. All right, let's try some crazy numbers. Let's give me a 99, a 0, a 56, a -1,000, and a 2. So in an ideal situation, we'll get -1,000, 0, 2, 56, and 99. Let's run it again. And that's exactly what we get. Perfect. All right, so yeah, that was our selection sort. Again, make sure you take your time to code this out yourself. Use this as a reference, and then once you get the hang of it, don't look at it and try and write your own selection sort program. The key is to test it, and don't skip planning it out, okay? This really helps you understand what the code is doing, and will save you a lot of headaches in the future. Anyways, thanks again for listening, for following along, and I hope you took a little bit of value from this video. Anyways, I've been the Web3 Idiot. Have a great day, great night, great evening, great afternoon. Bye-bye.